In this chapter, we're going to talk about hypothesis testing, and this is probably the most difficult but also the most important chapter of the whole class. When you use statistics to do actual studies, maybe in graduate school or in a job, hypothesis testing is usually what we do. Do be careful when you're reading the book for this chapter, because this is another chapter where there are some different methods and the calculator uses the p-value method. So don't worry about when they're talking about critical regions or test statistics. So the basic idea in this section is that we're going to be making a hypothesis or claim about the population, and then we're going to go through a very specific process of hypothesis testing, which will use evidence from a sample to either support or not support the claim that you're making about the whole population. This is a lot like other situations where you collect evidence and make a decision. Hypothesis testing is often compared to jury trials. You're not 100% sure, unless you were there, whether this person is innocent or guilty, but you collect the evidence and you make the best decision that you can. And that's what we'll do with hypothesis testing. We'll collect evidence from samples, use that to make the best decision about the population that we can, but you're never 100% sure that you're actually correct unless you do a census of the entire population, which is usually not feasible. And so I just want to emphasize again that the information that we collect comes from a sample, but we are using that to support claims about the whole population. You usually cannot survey the entire population, so you have to just look at a few people, collect some evidence, and use that evidence to form an opinion about the population. So, for example, I noticed that of the students in my classes, only 10% have green eyes. This might lead me to believe that a small number of Americans in general would have green eyes. For the whole American population, it might not be 10% like it is for my class, but I could probably say that I at least think it's less than 20%. That would not be unbelievable. So I have not checked the eye color of every American, but based on what I see in a sample, I can make a ballpark claim. So in the terminology of hypothesis testing, I see something that's going on in a sample, I make a hypothesis about the population based on what I've seen, and then I do a hypothesis test, which will actually take that data, make a calculation, and decide how likely it is that it supports my claim. So you are not 100% sure because you have not actually surveyed the whole population, but we can do a probability calculation on it to help us make our decision. So the theory underlying hypothesis testing is actually a detailed logic test. You make a claim about the population and then you look back at the sample and you say, if my hypothesis is true, how likely would it be that the sample happened? You're actually going to see that in a minute that we'll have two hypotheses that say opposite things. The first one will be the one that we test against the sample. So I'll say, if this is true, how likely is it that my sample happened? Well, if it's fairly likely, then it's possible that my hypothesis is true. And if it's not likely, then my hypothesis is probably false. So that will kind of be working behind the scenes with this hypothesis testing, and we'll come back to that when I actually have some specific claims to use as examples. And this is a flow chart that just kind of outlines what I was just saying. So you make your hypothesis, you observe the event in the sample, you assume that your hypothesis is true and calculate the probability that the sample happened. And then based on whether that comes out very likely or very unlikely, you make a decision. And we're going to come back to how these are phrased. You either reject the hypothesis or you fail to reject the hypothesis. You're never really sure. You're either sure that it's not true or you think that it could be true, but you're never really sure that it is true. And that'll be probably a little frustrating as we go through this, but keep it in mind. So I mentioned that we actually have two hypotheses. We call them the null hypothesis and the alternative hypothesis, and they say opposite things. The null hypothesis will always say that either your mean or your proportion are equal to a particular value. So maybe I saw a certain percentage in my sample, and so my hypothesis is that the population is equal to that same percentage. So that will always be the null hypothesis. We'll have an equal sign in it. And then the alternative hypothesis will go one direction or another, or actually sometimes both. So let's say that I am claiming that the population has exactly 20%, and then the alternative hypothesis would be that it is not equal to 20%. Or maybe my data indicates that it could be less, but definitely not more, so I might pick less than. Usually the data sort of helps make the decision which direction these should go, but you won't have to worry about that because the problems will tell you whether it needs to be less than, greater than, or not equal, so you won't need to worry about looking at the data to make that decision, and you'll see what I mean by that as we go through some examples. So let's say I have an example. I did a study, and in my sample it looks like the proportion of drivers who run red lights is greater than 50% or 0.5. So my sample made it look like it was probably more than 50%, so that's my claim. Okay, well, if it's a greater than claim, it has to go in the alternative hypothesis, H1, because the null hypothesis is always an equal sign. So I'm going to say, okay, I think my proportion, it's a proportion, so I'm going to use P. I think my proportion is greater than 0.5, and then the null hypothesis will be that same value, 0.5, but I'm going to change it to an equal sign. Okay, so what this is saying is my sample makes it look like it's probably greater than. If it's not greater than, it could be exactly equal to 50%, but based on my sample, it doesn't look like it could possibly be less than, so that's not even in here as a possibility. So we've just got the equal and the greater than as opposite possibilities. Alright, so let's say I've made a claim that the mean height of professional basketball players is less than 7 feet. This time I'm talking about a mean, so I'm going to use the symbol for mean. So I've got the mu here instead of the p. And I'm using population symbols because I'm making claims about the whole population. Okay, so in the alternative hypothesis, because it's a less than, that's where my claim's going to go. I claim that the mean is less than 7. And then that means that my null hypothesis, well, the null hypothesis is always an equal sign anyway, so you just fill in the exact same number, 7, and then change it to an equal sign for the null hypothesis. So that's what your two hypotheses would look like. This works a little bit differently when your claim is actually equal to a particular value. So in this case, my claim is that the mean IQ score of actors is equal to 100. Well, equal is always in the null hypothesis, so in this case my claim is actually my H0. The null will be that mu equals 100. Well, then what's the alternative? Is it greater? Is it less? Well, they didn't indicate that in the problem. You might be able to make a guess based on the sample data, but don't. If the problem doesn't specify, then your alternative will just be a not equal. So it's either equal or it's not. And so that's what your hypotheses would look like in that case. So here are 3 examples for you to try. Go ahead, pause the video, and take a look at these and see if you can sort them out. Alright, so as you're looking at these, pay attention to not only what the hypotheses look like in terms of the symbol, but as in greater than or less than, but also look at whether it's a p or a mu. You need to have that correct also. So mean amount is more than 12. That's an alternative. So H1 is mu greater than 12. That means I'm going to keep the 12 for the null but change it to an equal sign. So H0 is mu equals 12. If I think the percentage of viewers tuned to 60 Minutes is equal to 24%, that's the null. So my P this time, because I'm talking about percentages or proportions, my H0 will be P equals 0.24. I'm changing that percentage to a decimal. And then the alternative, well, I'm not really told whether it should be greater than or less than, so I'll just make it a not equal, P not equal to 0.24. And then if I think the percentage of men who watch golf on TV is not 70%, well, the not equal is an alternative possibility, so P not equal to 0.7. Once you know the alternative, the null, the H0, should be pretty easy. You just keep the number the same, change it to an equal. So always keep in mind with these, if you are putting an equal sign anywhere, it better be H0, better be the null. The alternative, H1, can either be less than, greater than, or not equal, Watch out whether you're using your mu or your p because it makes a difference. And either one can actually be the claim that you're making. So make sure that you keep track of which one you were actually claiming and then which one you filled in just based on that.